let's go find the area of the itty bitty tiny square. We're given this figure here. We have a large square with a circle inside of it. That circle has a radius of 5 units. Then we have 3 little squares right here, all of equal sides. All right, little points of tangency there, kind of, or this is barely touching. And we want to find the area of the itty bitty square. All right, let's go do it. I first am going to label my points of tangency with the circle. So right here at this point where it touches, let's call that A, and this point up here, let's call that B. And while we're at it, let's label our circle C. From there, I am going to connect these lines. I'm going to connect AC right here. Hopefully AC, make sure it's all lined up. Oh, well, that's good there. And BC, AC, BC. All right. Ooh. Don't drop the ruler there, or yardstick. All right. Well, since these are points of tangency, a tangent to a circle theorem here says that these must be right angles. Okay. And since they're also right angles, we also know each one's also a radius of the circle. So we can say that AC, that length, is equal to BC, which is equal to, well, 5. Right, a little length 5 here, and 5. Put it on the side. Then let's also label that point, I think I call it N up here. N up here, we know that, well, if it's a square, right angle, we have right angle, there's gonna be a square right here, right angle there. Across is also 5 here, and this is 5 as well. So we can just keep this gravy train going, and B is equal to 5, which is equal to NA. Okay? All right, now I'm gonna label another point. Let's call this point here M. Okay? So we have that point M, and we know that each one of these are little squares going on here. So let's go label that, well, the length of each one of these squares is X. We have X, 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 X right there. And if you want to put it on the inside, you can as well. Okay? They all will be labeled X as their lengths. So we can say that NA, like we said, has a length of 5. And then if we say NM has a length of 2x here, right? 2 of them. So the length of MA is equal to 5 minus the 2x. So it's kind of nice to have in terms of x's as well. Get a little constant here, and we'll keep on going. What I want to do here is I'm going to connect this point, and I believe I labeled it E, right here at the corner to the radius. Connect that here. We'll label this E. And again, this has a length of 5 because it's the radius. From there, we're going to drop straight down and create a good old right triangle. If I can make it straight here. And we have a good old right triangle here. And look at my notes, I labeled that point D. All right, so what we want to do is see if we can find out some information from this right triangle. ED has the same length as MA. That ED length here, so that's going to be a 5 minus a 2x. And if AD has length of x as well, right, matching up with top, DC has a length again of, well, that's 5 overall. AC has length of 5, but DC is 5 minus AD, which is just x. So DC is a 5 minus an x. You can see that's right there. Well, we have a right triangle. Pythagorean theorem is always our best friend, and we can probably use that to find x. So a squared plus b squared equals c squared. Good old Pythagoras helps us out here. We have 5 minus an x all squared plus a 5 minus a 2x all squared is equal to the hypotenuse squared, 5 squared. When in doubt, Pythagoras is your friend. Multiplying this out, 5 squared is a 25 minus, added up, minus a 10x plus x squared. 5 squared again here, minus, it's going to be 10, 20x plus a 4x squared is equal to a 25. Now we want to combine our like terms here. So we have 1x squared and 4x squared is a 5x squared. Keeping track here. Our x values, negative 10x, negative 20x is negative 30x. Got them here. Then we have 25 and a 5 squared, which is a 50. Right? 25, 5 squared is another well, actually here, let's be smart about it here, people. 25 cancels with that one right there. 5 squared is just a 25. And we have that equal to 0. So what can we do? Well, we can factor this out. Let's see if we can get it. But I see 5 goes in every term, so divide everything by good old 5. 5's cancel. We have an x squared minus, oh, that's going to be a 6x plus 5 equals 0. And now we have to factor what multiplies to be 5 but adds to be a negative 6. And that's a minus 5 minus 1. X minus 5, x minus 1 is equal to 0. So solve each one individually. X minus 5 equals 0. X minus 1 equals 0. X equals 5 or x equals 1. We got two options. What do we do? Well, can x really equal 5? Think about it. If our radius is 5 right here, can that little x value also be 5? It wouldn't fit, right? Because look, if we 5, that length would be 10. There's no way to fit the radius right there, okay? And that has to be the overall length. Clearly, 10 would be larger than that 5. So we can eliminate 5 as an option, and who would have thought it? Our radius, or our x value here that we're looking for is a 1, but again, we're not done. What's the area? Well, the area of a square, area, is equal to side length squared, which is, well, 1 units squared. So it's still 1 right there. I hope you learned something, and as always, thanks for watching.